This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 3, Lesson 2, Welded Joints in Bending and Torsion. Lesson 1 pulled the load straight through the weld, so the throat shear was uniform. Now the load misses the weld centroid, and the throat has to carry a moment on top of the direct shear. The trick is the same one every time. Treat the weld group as a thin line, look up its unit properties, scale them by the throat, and then add the direct shear and the moment shear as vectors at the worst point. Get those two habits right, and the bracket problems on this exam fall out. Here's the problem. A cantilever bracket is welded to a column by two vertical fillet welds. You're given the load, the standoff that makes it off-center, the weld leg, the weld depth, the spacing, and the electrode. Find the maximum throat stress, the direct shear plus the bending, compare it to the code permissible shear, and report the factor of safety. Two handbook items hold everything: the fillet weld properties table and the tables of electrode strength and permissible stress. Concept 1. Treat the weld group as a line. A bead is thin, so we model the group as a line of 0 thickness and read its geometry straight off the table: the throat area, the centroid location, and two unit properties: the unit second moment for bending and the unit polar moment for torsion. Those carry units of length cubed because the throat width hasn't been applied yet. To get the real second moment, scale by the throat, 0.707 times the leg. The handbook prints that scale step for bending. The torsion version is the very same construction, so we carry it. Just know it's derived, not quoted. Concept 2. The heart of the lesson. The direct shear is always present. Load over throat area, spread evenly, pointing the way the load pulls. The moment adds a second stress, and which one depends on how the load is off-center. If it's off-center out of the weld plane, you get bending, MC/I, at the farthest fiber from the centroid, acting at right angles to the direct shear, so the two add by Pythagoras. If it's off-center in the weld plane, you get torsion, TR/J, R measured from the centroid, and the worst point is where that torsional shear lines up with the direct shear. Either way, build both vectors at the worst point, add them, and compare the resultant to 4/10 of yield, the same shear allowable as Lesson 1. Concept 3. Pick the right row. The table gives one row per weld pattern, and reading the wrong row is the fastest way to a wrong answer. Our case is two vertical welds spaced apart. Throat area is 1.414 HD, and the unit second moment is d cubed over 6. Notice the spacing drops out of the bending property entirely because the bending is about the horizontal axis. The spacing only comes back for torsion, inside the unit polar moment. Match the picture to the row and copy the cubes and fractions exactly. Setup. Build two shears and add them. First, throat area and unit moment from the table row. Second, scale the unit moment by the throat. Third, the bending moment is load times standoff, and the bending stress is MC/I, with C at the far fiber. Fourth, the direct shear is load over throat area. Fifth, combine as a vector sum and compare to 4/10 of yield. The table holds the givens. Keep force in newtons and lengths in millimeters, and the stresses come out in megapascals. Solve. Part 1. The geometry. Two vertical throats give an area near 1100. The table's unit second moment is d cubed over 6. Scale it by the throat, and you land on the real second moment, about 9.4 times 10 to the 5th. Notice the spacing never entered. The bending property has no b in it. Solve. Part 2. The two shears. The moment is load times standoff. The bending stress at the far fiber is MC/I, about 127. The direct shear is load over throat area, only about 10. They act at right angles at the worst fiber, so add them as vectors. The resultant is about 128. Bending dominates, so the resultant barely clears the bending term, but you still combine them. When torsion is in play instead, the two often line up, and the sum is far larger. Solve. Part 3. The AISC table permits 4/10 of the electrode yield in shear, an allowable near 157. The factor of safety is allowable over the resultant, about 1.2. The weld passes, but the margin is slim, so a heavier load or a longer standoff would force a bigger leg or a deeper weld. And as in Lesson 1, that number is margin against the code allowable, not against outright yielding. Traps. 5 ways the moment weld bites. 1. The signature miss, forgetting to scale by the throat. The table's unit moments are line properties. Multiply by 0.707 times the leg to get real section properties, or your stress is off by a whole factor. 2. Measuring the lever arm from the wrong point. The distance to the far fiber and the radius in torsion are both measured from the group centroid. 3. Grabbing the wrong table row, vertical versus horizontal, single versus double, each has its own unit moment. 4. Taking the bigger stress instead of the vector sum. Combine the direct and moment shears, never just keep the larger one. 5. Comparing to a tension allowable. The throat is checked in shear, 4/10 of yield, the same row as before. Quick recall. Read the group's unit properties off the table row. Scale them by the throat, 0.707 times the leg. Bending gives MC over I. Torsion gets TR over J. The direct shear is load over throat area. Add direct and moment shears as vectors at the worst point, and compare the resultant to 4/10 of yield with an E70 electrode yielding 393. Golden rule. Weld equals line, scale by the throat, and add the shears as vectors. Next up, Lesson 3. Weld specs, electrodes, permissible stresses, and symbols. We leaned on 2 lookups this time, the electrode strength and the shear allowable. Lesson 3 makes those the main event. We'll walk the full electrode ladder, every permissible stress row, and how to read a weld symbol straight off a drawing, the leg, the length, and which side gets the bead. Everything's at PEPrepengine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide, with every equation and common exam trap, is free at PEPrepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.